Greetings everyone and welcome to my channel. In this video we are going to talk about K-means clustering. K-means clustering is a popular unsupervised machine learning algorithm used for clustering a dataset into groups or clusters. It aims to find K-cluster centers in the data, where each data point belongs to the cluster with the nearest center. Before applying K-means clustering, we would have a dataset consisting of data points represented by their features or attributes. For example, let's consider a dataset of customers' age and annual income. Each data point would be a combination of these two attributes, forming a 2D space. In this example, the algorithm tries to find two clusters in the data. It assigns each data point to the nearest cluster center based on the Euclidean distance. Euclidean distance is a way to measure how far two data points are from each other. Resulting cluster labels indicates which cluster each data point belongs to, and the cluster centers represent the average position of the data point within each cluster. As we can see, before K-means, it was just black dots, and now they are clustered into different colorful clusters: green cluster, red cluster, yellow cluster, and blue cluster. The purpose of K-means clustering is to group similar data points. It's commonly used in various applications such as customer segmentation, image compression, document clustering, and others. Choosing the number of clusters denoted as K in K-means clustering is an important step. There are few common methods for determining the optimal number of clusters. The first method is elbow method, and the second method is silhouette coefficient. Regarding the elbow method, we plot the within cluster sum of squares against the number of clusters. We look for a point on the plot where the decrease in the within cluster sum of squares starts to flatten out. The elbow point is often considered the optimal number of clusters. It suggests a trade-off between a lower within cluster sum of squares and a simple model with few clusters. The second method is silhouette coefficient. We compute the silhouette coefficient for each data point across different values of K. The silhouette coefficient measures how well each data point fits into its assigned cluster compared to other clusters. We look for the highest average silhouette coefficient, indicating better cluster separation and cohesion. We choose a value of K that maximizes the silhouette coefficient. Different methods may suggest different optimal values of K, and ultimately the choice depends on the specific dataset and the insights sought from the clustering analysis. Now let's dive into Python to implement K-means clustering. Firstly, we import our libraries. And then we generate some sample data. Then we create a K-means clustering model. We set the number of the desired clusters to K equal 2. Then we create an instance of the K-means clustering model using K-means from scikit-learn, passing in clusters equal K to indicate the desired number of clusters. And then we fit the model to the data. We fit the K-means model to the data using the fit method. This performs the actual clustering, assigning each data point to a cluster based on their attributes. Now we get the cluster labels for each data point. Then we get the coordinates of the cluster centers. We obtain the cluster labels for each data point using the labels attributes of the Kmeans model. Each data point is assigned a label indicating the cluster it belongs to. We also get the coordinates of the cluster centers using the cluster centers attribute. These coordinates represent the average position of the data points within each cluster. And now, let's plot the data point. And then we plot the cluster centers. And here we have it, the Kmeans clustering. By running this code, we get a visualization of the data points with different colors indicating assigned clusters, and the red X markers representing the cluster centers. This plot provides a visual representation of how the data has been clustered by Kmeans clustering. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.